I'm just going to take a super simple data set, which comes from the resource data about survivors of the Titanic shipwreck. And it's a small data set. It's got like 1,300 records. Okay, so before I actually do any transformations, I want to emphasize what the data model is. And that is the idea of the normal model for what it is. So let's do normal of Titanic, and let's take the first 3 rows of that. And that's a list of associations, okay? And so basically, the column names are the keys and the associations, and notice they're all the same, they're uniform. And the rows are the individual associations themselves. So for example, using this model, you think, okay, what am I going to do on this list of associations? Well, part would take, the first element would take the particular association out, and the second element would choose the key. So if I do, Titanic, the first 3 parts of that, I get the first 3 rows of the Titanic, because that would be the first 3 elements. And the normal of that, of course, is exactly like the normal I had above. And so when you think of the basic transformations, think of this model. Think of working on a list of associations. And I think if you have that model, it will be a lot easier to understand how the transformations work. Okay, so before I get, one more thing to talk about is the actual storage format. So for making efficient transformations, it helps to understand how the data is stored. So Tabular is stored in memory using a columnar format, as Jose showed. And each column has an element type, and that's both for memory and operational efficiency. And the column memory can be shared between different tabular column objects. So a tabular object itself is immutable, and a tabular column itself is immutable, but a tabular column can be shared between, amongst any number of tabulars. So it's a little bit like a Mathematica, a Wolfram language expression, but it's a vector valued expression instead of a scalar expression, which is what you're used to using. Okay, and then there's another command called from tabular that converts from tabular to various forms. And one of the forms that's particularly useful is columns. And if I look at from tabular of columns, I get an association of columns, okay? And this actually is very close to what the actual internal representation for tabular is. It's a bunch of keys, which is class, age, sex, and survive, and then these tabular column objects. And so there are going to be some transformations. And so if I can work on things that work with a column at a time, then I'm going to have things much more effective. Then there's some of the transformations actually work with this column-wise organization of data, as you'll see. Okay, so let's talk about what transformation commands there are. There are a lot. There's things like part, which selects parts, key drop, key take, those select things. Pick has been enhanced to work with Boolean tabular columns, so true and false values in tabular. There's sort and sort by, and delete duplicates by. And then there are new functions that are designed to work with tabular. And I'm going to focus in this talk on transform columns and aggregate rows, but there's a whole bunch of others. And almost all of these below are essentially based on transform columns. And in fact, any of the by functions are based on transform columns or construct columns. So understanding these 2 functions will get you a long ways in understanding, when you look at a new command, you want to work with tabular, understanding how that might work as well. Okay, so the first one is transform columns. So basically we have a tabular, we give a new column name and a function, and that creates a new column with name call by transforming the tabular data. So remember, in the data model, each row is an association. So within function, you can use pound survive to refer to the element of the association which has key survived, okay? And so when I run this transformation, I'm going to get a new column named S01 here, okay? And instead of having trues and falses, it has 0 and 1s. And you'll see in a moment why I wanted to do something like that. Another example is, let's just make this a little more compact. I'll call it Titanic 1, and I'll just make the sexes F and M instead of female and male, just to make it more readable. So that's an example of changing something in place. I changed this in place as well. So often you want to do chains of things in place because that gets you where you're going, and you just typically want to replace your table with one with columns replaced in place. Okay, so now there's one more that shows you the basic transformation, but there's also other types of transformations you want to do. And there's a thing we came up with column-wise value, and the description here is quite complicated. It does a lexical replacement of column, and I'm going to actually work through what that actually means. And what it allows you to do is it allows you to use column-wise things that have to be computed on a column-wise value in a row-based transformation. Because remember that transform columns maps over the rows. So we want to make sort of an exception to that rule is what this. And there's also a column-wise thread if you need to have the results threaded over all the rows. And I don't have any examples of that, but I think if you understand column-wise value, it would be fairly easy to understand. So here's a function. I'm going to call this, and sometimes it's convenient to define functions that I can repeatedly use, and I'll use this again a bit later in the talk. But basically, I want to have I want to classify ages whether they're older or younger than the median age. Okay, but to do the median age, I need the entire age column to do that. So I wrap column-wise value around that, okay? And then this value gets put in, and then it computes the age is less than or equal to that. So let's do that. And then I can do the transform columns of this, okay? And now I get a class of each person, whether they're considered old or not. And in my world, it's great. People 29 are considered old. I mean, don't trust anybody over 30, right? So we're close to that. And that's an example of creating a new column, which actually, and this actually categories as age in a sense. So it's a very simple transformation. So let's see how that actually works. So what I do first is I take, I'm going to show you. So remember that this is sort of a so I do this column-wise value, and so here's the median of the age column. So here I'm using from Tabular Titanic columns, okay? Remember, that's that representation. I show you that column-wise representation. Okay, and then I take the median of the age key, which is that tabular column, and a lot of functions have been overloaded so that they just work with tabular columns, such as median, mean, things like that. And that gives me the median age overall. Okay, and then I create a new function by replacing every instance of column-wise value with that value, okay? So now my new function, and this is the function that works row-wise, okay? And I get exactly the same results as before. So that's a quick example of how that's actually put together. Now, the internal code handles any number of column-wise values and so on and stuff, but it's really not much more complicated than that. Okay, so now let's look at the next function, okay, that I'm going to talk about. This is the aggregate rows. Okay, and this aggregate rows, the key thing to keep in mind is that it's going to work column-wise, okay? And the key thing about the idea is you have a group specification, you divide into groups, and you apply this function to each of the groups to get an aggregation over that group, and then you combine to get the results. And often the result is called, the method is called split, apply, combine. So we split into groups by the distinct values of the grouping columns. Okay, then we apply the aggregation F for each group, and that's done column-wise. So when you think of aggregation, aggregate rows, you need to think of that column-wise representation versus the list of association representations. And that's why I spent so much time at the beginning talking about those representations. And you combine, each row makes group. So let's do an example here. Okay, let's compare the survival rate by gender. Okay, females survive way more often than males in the Titanic. That's interesting. Now let's do another one, and you can use a transformation rule to set up a group. So here I'm using that old age function. So I want to see how did people survive based on whether they were older or younger. Okay, so that works very quickly. And what's interesting is there's an interesting weird thing here. Okay, so the survival rate amongst people who were older was 39% versus 42%. But what is this? Well, some of the ages were missing in the data. And so this is the survival rate of the people who didn't have an age classified. So when there's a missing thing, it'll translate through to that. And the operation of the old age actually propagates the missing. And there's really not time to go into that. Jose sort of showed that very briefly. Okay, so now let's consider, so here I've done one group. Let's consider two groups at once, sex and class, okay? So what it does is it takes distinct values of the list, sex and class, okay? And it shows this there, and it shows the survival rate. So the best survival rate are first class females, and the worst are third class male, or second class males, actually. Okay, and notice that these columns are emphasized in gray. They're what are called key columns, and to make key columns, it has to be unique identifier of a particular row. So in this tabular, if I say female and second, there's only one possible row that has that. So that's a way to have row keys as well. So now let's go one more step, and I'll show you how this command actually was done. The split, apply, combine. So first we split by group, and there's a group by for tabular, which divides the tabular into groups based on those groups. So here, female first, I get a whole tabular. Now, the internal stuff doesn't actually create the tabulars because that's a bit more expensive than necessary, but the idea is the same. Okay, so I have a tabular for each group, and then on each of those tabulars, okay, so I make a table over those tabulars. I do the from tabular of this with columns, okay, mean has survived, and that gives me my apply, okay. So for each of those tabulars and the values there, I do the from tabular, that gives me the column-wise representation. I compute the mean, okay, and that gives me the means of the survived. And then finally what I do is I combine them into columns, and here I'm adding the keys to make the whole tabular. Now this hasn't marked the key columns, but everything else in this table is exactly as it was above. So the last thing about aggregations is sometimes a really useful way to do an aggregation is to change the result of multiple, particularly when there's multiple groups. It's sometimes convenient to have a table. So this is actually the same results as above, but I've switched it so that gender goes down and the shipping class goes across. Okay, so it's very easy. It's much easier to make a comparison than it was in that previous tabular. And a super convenient feature of this that you can't do with just aggregate rows itself is this include group aggregates option. And what it does is it gives you aggregates for all the classes. So in this case, the all means this is survival in first class across all genders. This is the survival of all females for any class. And this is the survival of everybody overall in the Titanic shipwreck.